Good day. Welcome to Software Engineering online tutorial course. Today in this session, I will be taking a new sheet which is about state transition diagram. Okay. What is state transition diagram? State transition diagram is a diagram which is used to represent the states of an object. Okay. Generally, in state transition diagram, let me just show you the blackboard. Yeah, but it's called whiteboard. Okay, what is state transition diagram? Transition diagram is a diagram in which state transition diagram is a diagram in which you will have states. States are represented with like this circles. Okay, state one, and this is state two, and then you have a state three. Okay, these are the states. Okay, and from one state to another state you will do transition. Okay, so the arrow moving from one state to another state, we call it as a transition. Okay, so suppose this is stage one, and this is state two, and this is state, and you are moving from state 1 to state 2 using transition T1. Okay, and you are moving from state 2 to state 3 using some transition T10, like that. Okay, anything transition. Now generally you see here in a state transition diagram, you will have a initial state and a final state. Okay, what do you mean by an initial state? An initial state is a state in which we start our transition. So here stage one or transition one is our initial state. Okay, so generally initial state is represented with the help of this arrow. Okay, secondly, you have a final stage also. For example, you see state 3 is final state in this case. Then you, how do you represent this is starting state and this is final state? You see starting state, I just put arrow from here, and in final state you will put two circles. Okay, you will have circles for the final state. Okay, so using these notations we will be using state transition diagram. Okay, hope you have understood. Now let me give you one more example. One more example is, suppose this is your house. Okay, this is your home, right? And this is your college. Nowadays nobody want to come to college, right? And this is park. You have a park. Okay, now you as a student, when you are at home you will be in a happy mood. Okay, so your mood will be happy. This is the starting state. From home you will start. If you want to go from home to college, okay, home to college, then your mood will become bad. Okay, but from college to home, if you want to go, then your mood will become happy. H. Okay, I'm just giving an example. Now similarly, from home if you want to go to park, again you will be happy. Okay, you will be happy. From park to college you don't want to go, so you will be again in bad mood, right? So you see, using state transition diagram I am able to explain you what is your state at different point of time. When you are at home you are happy, but from home you can go to college using transition B, means using you are going to college and you are in not happy, you are in bad mood. And from college when you go to home, again you are happy. From college again when you want to go to park, again you will be happy. Okay, this is an example, okay, I'm giving, so don't take it seriously. So this is how in a state transition diagram you will show the different states of a student, that is he happy or he is in a bad mood, he is hungry or angry. All these are called transitions. Okay, this will take this will take an object from one state to another state. Okay, so depending on this, let us see our sheet state transition diagram now. This file which I have already shared with you, I think you have already downloaded this. If not, you can download it. you can download this sheet. Okay, you can also find this sheet in your online classes, all sheets together tab. You can click on it and you will get this sheet. Okay, so let me begin with the first problem. According to the first problem in state transition diagram, he's saying that draw a state transition diagram of control software for the software for a CD player. Now here, in your car, I think you have a CD player, right? Where you'll play Quran or some other material. You want to listen sound, or you want to listen you want to listen any kind of sound. You will use CD player. Now this CD player is an object. Now this CD player is in states. Okay, what are those states? Initially, when you buy a CD player, it is stopped. Okay, is it working? No, it is stopped. Okay, so now you see this is your initial state. So stopped is an initial state. Hope all of you are following me. I want chat messages S if you are following me. If you have any questions, please let me know. Do all of you are understanding? Okay, great. Thank you. Okay, great. So now this is when you first bring the CD player. Initially, it is in stopped state. Now, what happens? Suppose you want to play some verses of the Quran, or you want to play some voice. Okay, in CD player. So what you have to do is, okay, let me reply all. Thank you. Okay. So what happens is, from the stopped state, if you put the disk inside this CD player, what you will do, you will first press play disk in tray. Okay, you'll when you just press, when your CD player is stopped, you will press play. When you press play, uh, see here, when press play, what happens when you press play, then from stopped it will go to playing. Okay, now the CD which is inside your CD player, it will be playing. Now what is the meaning of this another disk, this transition? It means that, you see, generally on cassettes in DVD, okay, if one side is completed, it will turn on to the another side. Okay, so that is done automatically. If another side is also done, it will be stopped. Now, while playing, you can do two things. Suppose while you are playing some sound and you got a call, what you will do, you have two options. Either you turn off your CD player and talk to your friend, or you pause the CD player and talk to your friend. Okay, so that I'm showing here. Look here, when it is playing, let us take some other color. Okay, you see, when you press stop, it will again come to the stop state. The transition from playing, you are taking a transition called press stop, then it is coming to stop state. Or you have another option also, you can press pause. You can press pause. When you press pause, what happens? It's playing. No, it will be stopped temporarily, not permanently. So again, from pause, you can resume back. This is called press play again. It will be resumed back to playing. Okay, now when in a pause step, you have already a choice that from pause you can go to playing, or you can go to stopped. Okay, so now see, from this state transition diagram, from this entire state transition diagram, tell me, from this entire, sorry, yeah, from this entire state transition diagram, tell me, is it possible for me to move from playing to stop? Please give me answer. Is it possible for me? Is it? Yeah, good. How? It is possible from move from playing to stop using what transition? What is the name of the transition? Yeah, press stop. Okay, press stop. Good. Thank you. So press stop is the name of the transition which will be moving. Okay, great. Now, similarly, from playing, you can move to stop. Yes, you can move to stop. How? By pressing stop. From playing, can you go to pause? Yes, using pause. From pause, can you go to playing? Yes, using press play. From pause, can you go to stop? Yes, using press stop. These are the different workings of CD player is shown in this diagram. Okay. Now let's go to next question. I hope in operating system also you have seen state transition diagram, Nazam Tashghil, if you have taken this course. Otherwise, no problem. I will be discussing again. So let's take second problem here. State transition diagram for ATM machine. Okay. Now for ATM machine, he's saying that you have to show for single session transaction in detail, not all transactions, only single session transaction in detail. Okay. Now you see what happens, that this is your starting state. Okay. This is your starting state. Start state. Okay. Now you are starting from here. What happens when you go to the ATM? You will take your card and put into the ATM machine. Then ATM machine will read the card, right? That's what it is saying, that start, you are reading the card. When you read the card, now you see, I'm assuming that everything is happening smoothly. Okay, all these flows I will show you afterwards. All these are exceptions. Okay, I will show you afterwards. First, I will show you this normal flow. Okay, so let's begin. So you have first, machine will read the card. Now assume that when machine reads the card, it will ask you, when it is read successfully, your card is good, then machine will ask you to give the pin, the password. Okay, so when you provide the password and assume that your password is also correct. Okay, so pin will be reading, and pin is read successfully, then you have to choose the transaction. What transaction you have to choose? Either you want to withdraw money or withdraw cash, transfer cash, okay, pay some bill. All these are the type of transactions. Okay, now you see, when you are choosing the transaction, perform the transaction. Okay, after performing this transaction, what happens when you finish your transaction? The card will come out of the machine. That is called ejecting card and stop here. So this is the normal flow I have shown you. Okay, the red color what I have shown you is a normal flow. Okay, now I want to show you, 1 minute. Yeah, now I want to show you the exceptional case. Okay, so look here. Now what do you mean by an exceptional case? Something which happens unexpectedly. Okay, for example, when you put the card and suppose your card is not good, and it some strip has been damaged, so you cannot read it successfully. When you cannot read it successfully, it means card cannot be readable. If card is cannot be readable, then what happens? It should not ask you pin. You cannot do any transaction. Simply it should eject the card. You see, simply it is ejecting the card. Okay, if your card is not in a proper state to be read by the machine, then simply it will eject the card. Okay, now similarly, suppose your card is good, it is readable, it has read successfully, but you have given wrong password. You have given wrong password, or you have pressed cancel. Okay, so in this case also it has to eject the card. Okay, now in choosing the transaction, either you can choose the transaction, or suppose you thought, no, I don't want to do any transaction, at that time also you can press cancel. So whenever you press cancel here, again it should give you your card back. Okay, now you see here, when you perform a transaction, after completing the transaction, here I have told you that only in one transaction, but in a single session you can do multiple transactions. So suppose you want to withdraw, suppose 10,000, you cannot do this in one go. First you have to take 5,000, then 5,000. Okay, so you perform first 5,000 transaction, then again the customer want to do another transaction. Okay, so again you will go back and again choose transaction of transfer and do another 5,000 transfer. Okay, now after that you finish. Now suppose, you should also see that when you are choosing a transaction, during that, when you are performing a transaction, so you see here this case, you read it properly: aborted due to too many invalid pins. Aborted, I think this is not written properly, I'm writing here. Aborted due to too many invalid pins. Card is, and what it means, let us understand. Look here. Here, while performing a transaction, you have given your pin wrong one time. Okay, acceptable. If you have done this mistake one time, okay, no problem, it will give you one more chance. Two times. If you have done three times or more than three times, then what happens, you see, it is not giving you card will be taken back by the machine only. It will be held up back by the machine, and you will be stopped directly. Okay, so you see in this transaction, okay, card is not in your hand. Now next day you have to go to the bank and ask the people and show the proof that you are the correct person and take your card back. Okay, so this happens only if you do lot of, okay, many invalid pins. If you have tried many invalid pins, then this problem will arise. Okay, so this is about ATM machine. So all of you understood how ATM works? Okay, shall I go for next? Shall I go for next? Okay, thank you. Let's go for the next thing. Next question. Okay, thank you, brothers. Yeah, this is question number 3. State transition diagram for microwave oven. I think most of you are having microwave oven at your home, okay? And nowadays we are all at home, so you might be using it more number of times. And if you have not used it, you can check it now also. But don't leave the session and go. Just listen to me. In this state transition diagram, I would be showing you how this microwave oven works. Now, look here. This is the starting state. Okay, this is the starting state. Initially, when you bring the microwave oven, it is not working. It is not in use. It is closed, right? The doors are closed and it is not in use. Now, suppose you want to you have a burger or you have a pizza, and you want to you want to make it hot. Okay, what you will do? Initially, when you start, your door is not in use and door is closed. So what you will do? First, you have to open the door. How do you open the door? You just click this press release, press door release. When you press door release, see, this is your pizza. Okay, so you want to put into this oven. So what you do? First, you click this press door release. Now door is open. When door is open, put this pizza back here. Okay, when you put this pizza back here, what happens? Okay, this pizza will come here. Okay, so this pizza has come here. After this pizza come here in the open, now close the door. You just press close door. So now what happens? Door is closed. After door is closed, where is pizza? Pizza is in microwave oven. Now you can give timer to heat this pizza now. Okay, so that's what you are doing here. Set timer and press start. You are pressing for 2 minutes or 30 seconds and pressing start. Now it is heating. It is heating. What is heating? This pizza is heating and some flames are coming from this pizza. Okay, ready to have it now. So what you have to do is, after heating is completed, after finish heating, then what happens? You will it will stop automatically. Okay, so now again what you have to do is press door release. Now door will open. Now you take out this pizza here, hot pizza, outside it. When you take your hot pizza outside, now pizza will come here. Okay, some flame is coming. This is hot pizza, right? Then you close the door. Now your pizza is ready to eat. Now you see in this state whole transition diagram, I will ask you one question. Okay, the question is, tell me, while I am heating this pizza inside this microwave oven, can I open the door? While it is heating, can I open the door? Just see this and tell me. See this diagram and respond me. While heating this pizza inside the microwave oven, can I open the door? No. Very good answer. Muhammad Ahmed. Muhammad Al-Baqi. Yeah. No. Why? Because you see, when you are heating, okay, when you are heating, you cannot open the door. There is no transition from heating to door open. Okay. So the right answer is yes. While heating, we cannot open the door. Now, what doctor will do is, generally in examinations, he will change this question. How? Draw the state transition diagram for microwave oven, and this microwave oven should allow you to open the door while you are heating the pizza. Okay, he has changed this condition now. Now, when he has changed this condition, yeah, here is the door cannot be opened during heating. But if the condition is given that the door should be open while heating, now tell me what you have to do. Any answer? If I want to change, I want to put this condition that after heat, while heating, I should able to open the door. No, not stop state, but good try. What you have to do is very simple. You see here, from heating, you should draw a straight transition to the door open. Finish. Okay, and give the name to this transaction while heating plus door release. Finish. Okay, so if you add this transition, now what happens? Okay, this is a microwave oven in which you can open the door even while heating the pizza. Okay, earlier if you don't put this, if you don't put this line, if you don't put this line, then this is correct. Door cannot be open on heating the pizza. If I want to open the door, I want to cut this, the door should be opened while during heating the pizza, then I should add this. Okay, so this is how the changes has to be done in state transition diagram. Okay, so let's go for the next problem. Okay, shall we move to next problem now? Problem number 5, state transition diagram for process management system. Now this is what I am talking about, that in Nazam Tashghil, in operating system, we have state transition diagram for a process. Okay, now see here. uh, Okay, well, I'm sorry. One more important thing in question number 3. This is starting. I have told you already. But what is ending state? Can any one of you tell me what is the ending state? Here it is showing that it is ending state. Okay, or if you can cut this, if you remove this, you can make this also as a starting and ending state as same. Okay, give 2 circles. Yeah, correct. After door open, this is also there. You can put like this also, or if you don't want to put, remove this and you can give this, because starting and ending state is not in use and door is closed. Okay, this is same. You can give in this. Okay, now here you see in state transition diagram, this is your starting state. Okay, new means just the process has been loaded into the main memory and it is waiting for its turn for the CPU to be executed. Okay, now what do you mean by ready means this new process is brought into the main memory using what? Admit from new. If the transition is admit, it is loaded into main memory. Okay, now suppose a main memory has ability to store, suppose 4 processes in its main memory. Okay, but you have 40 processes, new 40 processes are there in the system. So what happens? Process 1 is allowed to stay in the ready queue. Okay, 2 is also allowed, 3 is also allowed, 4 is also allowed, 5th cannot be allowed because already capacity is over. So now what happens? From the 5th process, you will not allow to come here. What you will do is you will allow those 5th process okay, to go into the secondary storage. Ready suspended is also like a ready, but what is the difference? In ready is nothing but this ready is in main memory and this ready suspend is in secondary storage. Okay, so you will suspend some processes, you will suspend the processes while coming, so it means all the remaining 36 processes will be in storage. In storage you have lot of space. Okay, so this is ready suspended. So ready means it is in main memory, ready suspended is in secondary storage. So how you move from ready to ready suspended? Using suspend as a transition. And suppose here we have finished these 3 processes. Okay, now you can accommodate 3 more processes. At that time activate is transition happens, which will move some of the ready suspended processes to ready state. Okay, so now just see here, is it possible to move from ready to ready suspended? Yes, it is possible. Using what? Using using suspend transition. Now is it possible to move from ready suspended to ready? Yes, it is possible using activate transition. Is it possible to move from new to ready? Yes, using admit. And using admit, it is also possible to go to ready suspended. But when it goes to ready suspended, main memory is full, then it will not be admitted into main memory, it will be admitted into secondary storage. And generally in context of computer science we call it as a swap space. Okay, this is called a swap space. So now we have understood these three states. New, okay, new means just newly created process. This is in main memory, this is in secondary storage. Now from ready, if the process is waiting for CPU, now CPU is, suppose two processes are waiting here, and process first process is given chance to run. Okay, given chance to run, then it is called dispatch. It is called as dispatch. From ready to running, a process can be moved from ready to running. What is the difference between ready to running? Ready means it is in main memory. Ready means it is in main memory. Running means the process is given CPU. Here process is given CPU. Okay. Now what happens? Is it possible to move from ready to running? Yes, it is possible to move from ready to running using a transition called dispatch. Okay. Now you see that in sheet 2 of Nazam Tashghil in operating system, if you have completed this course in CPU scheduling algorithms, we have seen round robin and all, right, with preemption, non-preemption. So generally in preemption algorithms, you have timeout. It means while running for some time, again it will come to ready and it will be executed in next time slot. So is it possible to move from running to ready? Yes, using timeout state transition here. Okay. Now see, there is one more thing. Is it possible? I'm just asking you one question. Just see this and tell me: is it possible to move from running to ready suspended? Is it possible? Yeah. Right answer. Yeah. How do you know? Yes, because yeah, you just see this. Do you see this line? This line. Yeah. Yeah. Good. Very good. Thank you all. Yes. So it's possible to go from running to ready suspended. It means from CPU directly it is sent to the secondary storage using suspend. So you remember, suspend is used not only to move from memory to secondary storage, but suspend is also used from taking a CPU back from the process and putting the process back into the secondary storage. Okay, that's great. Now you see here, similarly when a process is running and it want to do some IO operation. Okay, so far we have seen how many states? We have seen new, we have seen ready suspended, we have seen ready, we have seen running. Okay, now let us understand what do you mean by block. Suppose while a process is running and it want to do some input output operations and it want to execute some sleep command, or it want to do some printing, then we need to stop the process for some amount of time. Okay, and give its chance to do its printing. That is called event wait. Okay, so a process will go from running to block, event wait. When the event elapses, when the event occurs back again, it will now it will not go directly to the running, it will go to the ready state. Now I'm asking you one important questions from this. Tell me, is it possible to go for a process from block state to running state? Answer me. Is it possible to move a process from block state to running state? Any answer? No is the right answer. Muhammad Umair, your answer is right. If you say yes, no, it is not correct. Now, why it is not correct? Do you have any line? Do you have any arrow from block to running? No, you have arrow from running to block. Okay, so the right answer is that in a process state transition diagram, you cannot move block to running. But the question is then how from block state, if a process is blocked, I want to run it, how can I do that? It's very simple. First, you have to unblock this process using event occurs, it will go to ready. Then, okay, no problem. Abdul Muhammad Ibn Mari. Yeah, no problem. It's okay. This is how we can learn from our right and wrong answers. Okay. First, for block process goes to ready, and then from ready you can go to running. So indirectly you can go from block to running through two state transitions. One is event occur, then dispatch. Okay. Now, what do you mean by block suspended? Let us understand this block suspended. What do you mean by this block suspended? Now, suspended means in main memory you have capacity for blocking only suppose 3 processes, but CPU is blocking 10 processes. The problem is after 3, 4, 5, 6 all processes cannot be blocked in main memory. They will be suspended to go back to the block suspended. Okay, so now remember, new, ready, running, all these states are using main memory. These are all with red color. Sorry, just I'll show you with red color, all are using main memory. Okay, these are all are using main memory, and I'm using green color, they are using secondary storage. Okay, they are all using secondary storage. Okay, and these all are using main memory, remember this. Okay, if the process has completed its execution, exit at the last stage. Please do this change. What is the final state here? Starting state is new, right? So you have starting state is new. So for new, you put like this arrow, and for ending state, because exit is the ending, you have to put 2 circles. Please do this modifications. Okay, you have to put this 2 circles. This is exit. So this modification you have to do here. Okay. So let's go back to next problem now. Okay, this is state transition diagram for process state transition. Yeah, this is also a state transition diagram for fork. You know already that fork is a system call. Yeah. So fork is a system call that creates a child process. This explanation is same as the previous. This is the process. So just do these changes. This is the starting state fork. From fork, okay, it is going to ready. This is nothing but ready from the previous diagram. Okay, current is nothing but running. Wait is nothing but block. Task zombie, actually this is a bad word, but it is used in the literature. I cannot avoid this. You have to use, but this is the bad word to be used. But this is nothing but your terminated exit. Okay, so make this as an ending state. This ending state. Okay, from fork, this is nothing but new of our previous state transition diagram. I will just show you again. Yeah, this is starting state, and this is ending state, and this fork is nothing but new. Okay, this is nothing but ready. Okay, and this is nothing but running. This is nothing but block. What I have shown you in the previous problem. Okay, so only these names are different. Only they have given for fork, names are different, but its explanation is same as new means a new process gets created. So fork creates a child process. Task running is nothing but a ready queue. Current is nothing but the process which is currently running on the CPU. Here wait queue is nothing but the process has been blocked for a specified amount of time. So process when it executes sleep, it will be sleep for some amount of time. When it's wake up again, it will go to running, and again preempted context switch. Name of the transition. I'm just writing the alternative names which we have used in the previous problem. This is nothing but admit. Okay, which we have seen in the previous things. Okay, same as admit. What do you mean by context switch? This is nothing but dispatch. Okay, this preemption. What do you mean by this preemption? It means again you are coming back. There is one transition to come back. Do you remember what is the transition? The transition to come back is, I think, time out, right? This is time out. Okay, and the process termination is nothing but here exit. Yeah, and the sleep is nothing but wait for event. Okay, and wake up is nothing but event. axis. Okay. So this what I have put in examination. Don't put this in examination. You have to draw what is there in the black. But I am just telling you the conversion from the previous question number 4. The explanation and this explanation are same, only the names are different here. That one, that is what I need to convey the message with you. Okay. So let's move to the next part, next question, question number 6. Shall I move to question number 6? Okay. Do all of you understood this? Yeah, it's clear. Thank you very much. So one thumb and one rainbow for all. So let's go for next session. Next slide. Oh yeah, you see, this is I think this is a game. Actually, game development. Let me just say, stop. Yeah, game development in most of the software companies, they create games, okay, in mobile phones and all. These games are also developed with the help of this state transition diagram. Okay, so let me explain you this game. What is a game? This is the game here. Oh no, we have one more again. Okay, please correct it. This is question 5, so this will be question 6. Okay, this is question number 6. Okay, question 6. Okay. Yeah, we have 2 games here. One game is Shatranj, Shatranj, chess game. Okay. So question number 6 and question number 7 are about 2 games. So it is very interesting to know these games. Let us understand how this game development is done in state transition diagram. Okay. Most of you know Shatranj, how to play Shatranj. Chess, we call it in chess game. Nobody knows? Yes. Okay. So you see that, yeah, if you don't know how to play this game, it's good. Not actually. Okay, no problem. So if you don't know how to play, don't worry. Okay, if you know how to design the game, most of the people who design games don't play games. Okay, they only make people play games and they will learn. Okay. So let's see. Don't worry if you don't know. I'll just give you a brief overview that how this state transition diagram. Yeah. So how this state transition diagram is helpful in creating the functionality of game process. You know that in game, you have a square box of 8 by 8. Okay, you have this, and you have 8 rows and 8 columns. Okay, like this, and you have all camel, elephant, prince, and king, and here all spy. You have one car white color and another is black color. Okay, so you will have all this at 2 sides. Now, generally when you start, you will start this game with the white turns. Okay, so that's why you have 2 states in this game: white turn and black turn. Okay, and you are starting with white turn. Okay, so when there is white turn, now there is a possibility that when the white want to move, okay, he can be able to. I think you are unable to see this, what is written properly. I will just write down. This is black moves. Black. Okay. Black moves, and this is white moves. Yes, yes. Okay, no problem. Yeah. So black moves and white moves. Okay. This is called stalemate. This is called checkmate. This is a draw. This is not clear, that's why I'm writing here checkmate. This is also stalemate. Black wins white. Okay. In the game, what happens? this game has 3 outputs. Okay, how many outputs? 3 outputs. One output is maybe white wins. Okay, second, maybe black wins. Third is nobody wins. That is called draw. This is called draw. Okay, so game may end either by winning of white or winning of black or in a draw mode. That's why you have a starting state and ending state as black wins or draw or white wins. Okay, now before this win happens, they have to play the game. How the game will be played? When it is white turn, okay, then black, then what happens? White moves. When white moves, black turns will come, and black moves, then white turns will come. Alternatively, both have to play alternatively. Okay, now during this play there is a possible that at some point of time, if white is checkmate by black turns. Okay, if white is checkmate, then black wins. If black is checkmate by white, then white wins. Now what happens is, in some cases, nobody can checkmate any one of them, and what happens is, in any white or in black, only king remains. And if he has taken 16 steps and he could able to defend in 16 steps, then the game is drawn. Okay, so stalemate, we call that state as a stalemate. Okay, so this has been uh, from this we can understand that the chess game has 3 outputs. You can either black wins or a wins, or it can be a draw. How this game is played? You will start with either white's turn. If white is starting, so first white will move, then black may move. White move, black moves. They go on moving till any one of them is checkmate to black wins, or checkmate to white wins, or stalemate to draw. Okay, so from this we have understood that in a state transition diagram it is possible that you have multiple endings. Okay, so this you remember what conclusion we have to take from this. The conclusion is, a state transition diagram may have a state transition sorry, it's unable to write. I'll write here. A state transition diagram have multiple end states. Okay, so a state transition diagram may have multiple states. Now let's see question number 7 now. Okay, now in this question number 7, man, wolf and goat. This is very interesting game. That assume that here a fisherman is living. He is living with man, wolf, goat, and cabbage. Okay, now man, man means nafar. Okay, and wolf, it likes a dog, fox, wolf. You know this in English, wolf. Goat is nothing but ghanim, goat. Okay, cabbage is a vegetable. Cabbage is a vegetable. So if man is not there, then what happens? Goat will eat cabbage and wolf will eat goat. So we should avoid this. If man is not there, then wolf will eat goat and goat will eat cabbage. Now the task is, the man, wolf, goat, cabbage, they are here, and there is some river in, okay, and river, and he has to go to another house here, and he has one boat. Okay, the condition is the boat can have only it can carry only 2 people. If man, wolf can go, or wolf, goat can go, but if you put 3 things, then it will soak. Okay, so this is the condition. Now the game, you have to develop a game in such a way that man should take all these 4 items across the river. Okay, so this is the game explanation. Okay, this is what in English is written as what I have explained you. Okay, let us see the solution for this. Now look here. Start. Initially, man, wolf, goat, and cabbage are at the home side, and this is river, and other side nobody is there. Okay. G means what? Man is going with goat. See here, man is understood because who will ride this boat? Man. Okay, wolf, okay, goat, they are animals, they cannot ride the boat. Okay, so it means man and goat is going. Why goat is going? Why? Because if I don't take goat, then wolf will eat goat. If I keep goat, goat will eat cabbage. But wolf will not eat cabbage. Okay, so that's why wolf and cabbage we put here. Okay, and make man and goat goes to the that part of the river. So using transition G, you see here man and goat went there. Now after that, what happens? Man come back. Okay, you see man come back alone, leaving goat here. Man come back alone. Okay, now if again man goes again, it will go to the previous. See, if you are taking G and coming to next step, then from here if you want to go back again, take G to this, you will go to the previous step. That is the meaning. Okay, then man, what he will do, he has two chances. He can take wolf or he can take cabbage. Okay, both are correct answers. Now let us see first, if a man has taken wolf, man is taken wolf, so cabbage will be remaining here. So cabbage is remaining here, man, wolf, goat will be here. Now there is a danger here. If man comes alone, then wolf will eat goat. Okay, so what happens is man will take goat back. So you see goat is taking back, so only wolf is remained here. Only wolf is remained here. Okay, so and what happens, man and goat comes here, man, goat, cabbage is here, and wolf is here. Now because man is there, goat is not eating cabbage. Okay, so now what happens is man will take, man cannot take goat. If you take goat again, you are going back, you have to take cabbage now. So man will take cabbage, so that goat is alone, it cannot eat anything, and man will put cabbage beside wolf. Wolf cannot eat cabbage. Okay, so again what happens is only goat is remaining. Man will go to the goat and take goat back to this. Now you see at ending state, I have four people here, man, wolf, goat, and cabbage. This is river and this is another home. You see the ending state here, at another home nobody is there, all of them have been shifted to this home. Okay, so similarly you have another flow. From here you can take cabbage also. This is an interesting game, and you see you may take any number of combinations to get this done. Now I will one question. Tell me, in this game, is this the following transition correct? Tell me. The transition I'm writing as G M M W G C M G. Tell me, is it correct transition? So you see, first I take G. From here I take G. I come here. Then M. Using M I take here. W means I take, no, again another M, I go back. From here I don't have W. So this is wrong. Okay, this transition is wrong. Okay, now I will ask you one more. Tell me, what about this transition? Is this transition correct? G M M M C D W W M. Tell me, is it correct? Is this transition correct? Now you see G. I'm coming from here. G. This is finished. Then M means from G to M I come here. Again M, go here. Again M, again come here. Then C. C means coming here. C. G means come here. W, come here. Again W, go here. Then M. Yeah, this transition is correct because it is starting from initial state and taking me to the ending state. Okay, so this transition is correct. Understood, all of you? Hope you are following. Okay, good, great. So let's move to the next part. From here, you have all interesting things. Now you see here. Now I think those who have taken course with me about C language or C++, okay, you will be understanding this. You have something called data types in C language, okay, or in MATLAB also data types. Okay. It is about that for rules for creating data types. Identifier can be defined as a string of letters and digits that begins with a letter. Now you see he is saying that I'll just give you for example. I'm just giving here. Okay. If I give examples, you will understand nicely. Okay. That's why I'm giving this example. What is the example I'm giving? Let us see here. An identifier can be defined as a string of letters and digits that begins with letter. So suppose I gave A 1, 2, 3. This is one. Another is 1A, B, C, D. Next is A 1, 2, 3, 4, C, D. From this. Yeah, any question? Do all of you able to hear me? Okay, you can decide the time. You can decide the time. Okay. I will come to the activity. Don't worry. Don't think about the activity. When I finish this lecture, I will come to the activity and what are your convenient. Inshallah, I will help you in doing that. Okay. Don't worry.
Doctor,
Yes, brother.
about the quizzes, Doctor. The quizzes is so hard for the time you given us.
Okay, I will increase the time. No problem.
Okay, or you can, Doctor, make it easy. That's
It's easy only. You see, I'll tell you. Let me finish this lecture, then I will come to the activity. Okay.
okay. Okay.
Don't worry. And Muhammad Umair Muhammad Al Ahmari, for other section it is different. For your section it is different. Okay, so it is better. I want to keep section wise it differently. So don't ask about other section. They will decide and give me the slot, and I will, according to their convenience, I will activity for them. And for your section, you decide, all of you, and tell me. For you, I will give you your time slot. Okay. So don't worry with other sections. It's not necessary that all the sections should have on the same time. It is section wise, your convenience. Okay. Okay. I'm audible. Okay, no problem. Okay. Let me ask you this. Now look here. What do you mean by an identifier? An identifier means it should start from, you see, it should start from letter only. Okay. Then it is called an identifier. Now you see, tell me, is it an identifier? A 1, 2, 3 is an identifier? Yes. It is starting from letter. Letter means what? Letter means small a to small z and capital A to capital Z. Okay. In digits are nothing but 0 to 1. So you see this is nothing but letter L and this is nothing but digit D. Okay. So an identifier is always starting from letter. So A is a letter, correct? So it is an identifier, correct? But is one ABC is an identifier? No, this is not an identifier. Why? Because you see it is starting from 1. Okay, and 1 is not a letter, it is a digit. It's not an identifier. Okay, do A 1 2 3 4 C D E B is an identifier? Yes, because it is starting from letter. Okay, now the question is, we have to draw a state transition diagram that should accept only identifiers which are starting with letter. If it's starting with digit, don't accept it. For this, This is the state transition diagram. Okay, for this I have a state transition diagram. This is the state transition diagram. Let us see how a is letter, right? So from starting state using a, I come to final state. Then letter, you have digits 2 3, these digits, so your ending state, it is accepted. See, this is accepted. Okay, now when you see starting from 1 is digit, you see using digit. Okay, please write down here. From starting state using digit, can you start here? So this is not acceptable. You see, if you are using digit here, from using digit you cannot go to final state. That's why this is not accepted. But you see, a is letter, then 1 2 3 4 is digit, then c d e b is letter. So you are in final state. That's why it is acceptable. Okay, that's why it is acceptable. Okay, so now let us see another problem. You will understand nicely. Draw the state transition diagram for the set of strings that ends with 0 0. So let me give you some more examples in this case. Okay, suppose I have 100 and I have only 0 0. I have 0 0 1 0. Then I have 0 0 1 0 0 1.
Doctor,
Yes, brother.
next lecture, can you make the quality of the sheets more clear?
It is clear only when you go to the Blackboard and see, because I am sharing this in Blackboard, it is showing me like this. Okay,
Doctor, if you upload this
I
file,
uploaded already.
okay,
You can
but,
go to the go to the online courses. There all sheets together I have put it. I will show you after the lecture where is the material. Okay,
okay, Doctor, but if you share the desktop of in the Zoom, it will be better.
in Zoom.
Yes.
No, the Zoom is having lot of issues, lot of problems, because most of the students they need to install the software, and they are facing difficulty with Zoom. And this Blackboard Collaborate Ultra is excellent.
With Dr. Abbas, we already upload the software and we are using it for many lectures, not only
You
this.
are using for many lectures. Okay,
Yes, yes.
let me.
Dr. Saidi and Abbas, Dr. Zakaria also, we are all using it. It's because it's better quality and you can share the desktop immediately from your.
Okay, let me ask the others. Okay, if all are agreeing, we will shift it to the Zoom. Okay,
Okay, no problem.
but till then, we will do this. Okay.
Okay.
Yeah, thank you. So now, see here. Tell me, is 100 is ending with 0? Yes. So it should be accepted. Is 0 0? It is starting and ending with both 0 0. It should be also accepted. But tell me, is it ending with 0 0? No. So this should not be accepted. Okay. And this is also not be accepted. So we have to draw a state transition diagram that should accept a string that ends with 0 0. Okay, so for that, you see the state here. I'm just starting here. This is the starting state. Okay, now you take first 0 and second 0. If you end it, it is acceptable. But after 2 zeros, if you have, so after 1 0, if you have 1, come back here. If you have any number of ones, no problem, you will be here in state. But at end state, again after 2 zeros, if you get any one, go back to the initial state. Okay, so this is the state transition diagram. You see, this will accept only strings that ends with 0 0. Let us see now. You see 100, you have 1. Okay, taking 1, I will be in QS. Then 0 0. Yeah, I reached the final state. That's why what happens, this is 100 is accepted. 0 0 0 0 is accepted. But you see 0 0 1 0, let us see. 0 0, again 1, again 0. See, you are not in final state. That's why it is not accepted. Okay, let us see this. 0, 0, again 1, again 0, 0, again 1. You see, you will come back to the final state. So what happens? This is also not accepted. Okay, tell me, will this string will be accepted? Is it accepted? Yes, because it is ending with 0, 0. But our transition diagram is not accepting this. It means there is some modification we have to do here. See, 0, 0. After 0, again, you have 3 more zeros. It cannot go anywhere. So this is not accepting. So to make it accepting, please add this. You have to write like this, self, and put 0 here. So after 2 zeros, it can take any number of zeros. Now this will be accepted. Okay. So please do this change in your sheets. The change is you have to put 0 at the end. After 2 consecutive zeros, you can have any number of zeros. Okay. So this is the change you have to do. Let's see the last problem. Draw a state transition diagram for the set of strings that contains 3 consecutive zeros. I think the solution is not visible properly, so I will use, okay, set of 3 consecutive zeros. I will use whiteboard. Yeah, here. So let me use this. So I have one state, I have another state, I have, okay. So this is starting state. Okay. So I take this is as starting state, Q which is taking 1 0, Q which is taking 2 0, and Q which is taking 3 zeros. Okay. Now you have to draw a state transition diagram. See, I'm just drawing here. The question is you have to draw a state transition diagram that has 3 consecutive zeros. Okay. What do you mean by 3 consecutive zeros? So let us understand here. If you have 3 zeros, what to do? If you have 0 0 0 1 0 0 0 0 1 0 1 0 0 1 0 0 0 1 0 0 and 0 0 1. Now see, from this there are 3 consecutive zeros. Yes, you should accept this. Here also you see you have 3 consecutive zeros. Okay, you should accept this. Here no, you don't have, you have 3 zeros but not consecutive, so don't accept it. Now here you have 2 zeros, but yeah, here you have 3 zeros, consecutive zeros, so you can accept it. Now here also you can have 3 consecutive these zeros, or you have this this 3 zeros. Okay, so accept it. So it means maybe in the beginning, in the end, or in the middle, anywhere, if you have consecutively 3 zeros, you should accept it. Otherwise, you should not accept this. Now we have to draw the state transition diagram for this. Okay. So for this, look here. QS, if you have any number of ones, no problem. You will be here only. Okay. But if you take 0, this is 1 0, this is 0. Taking 0, you go to Q0. But after 1 0, if you get 1, again come back here. Okay. Then suppose if you take another 0 from this state, you go to 2 zeros accepted. But from here again, if you got 1, go back to again. This is previous state. Again from 3 consecutive zeros. Now this is the final state, you have to accept it. Now after this final state you get 3 consecutive zeros. You can have any number of how to erase it. Yeah, any number of 0 or 1. Okay, now see here 0 0 0 from starting state 0 0 0 accepted, right? So this is accepted. Then you see 0 0 0, then again 1 0 0, any number of zeros and ones accepted. You see 0 0 1 0 1, see 0 0 again 1, then 0 again 1. You are in final state, that's why it is not accepted. And you see all this remaining will be accepted. Okay, so please take down the solution. This is the solution for state transition diagram that has 3 consecutive zeros. Okay, now the next part is about activities. Okay, now let me share you and my screen and give you some information. Okay, now look, all of you, hope you are seeing my screen. You just click on this online classes. Okay, when you click on this online classes from your Blackboard, okay, you will see the activity 3. But before starting the activity 3, make sure that you have completed this PPTs. Okay, so this activity is from this PPTs, chapter 3 and chapter 4. So first read it and complete the activity. After completing this activity, after completing this reading the material, you can go for the activity. Okay, and about the sheets, you see here all sheets together. You have to click on it. When you click on this, you will get all the sheets. Friends, you see all the sheets here: software engineering question, class diagrams, okay, function sheet, sheet 4 and sheet 5. All these sheets are available. Class diagram and this current sheet 6. Let me add this sheet also for you. You have this state transition diagram sheet also. Okay, so I just submit it. Now you see you have all the sheets with you available. Sheet 6 state transition diagram also. Next week we will be taking class diagram. Okay, class diagram questions and solutions are all available. Okay, now regarding this activity, click on this online classes. Okay, you have an activity. You can start the activity after reading that. And because most of you told that you need some more time, so I have increased the time to 30 minutes. Okay, so the time is 30 minutes for it. Complete this activity in 30 minutes. So when you want to do, at what time you want to do, please message me so that I will put this activity on that time. Okay, yes.
Can you open this activity for today and tomorrow?
I cannot open this for a long time. You just tell me the time, I will open it for you. Okay,
Because Doctor, we have the project files we need to work on, and also we have a test for the lab, mid one.
okay, no problem. So you want me to do it today and tomorrow?
Yeah, just let it open today and tomorrow. Anyone who can enter the activity, if he have free time, just for 30 minutes, he can solve the question and he go out.
Okay, brother. I will take that point, no problem, because to help you, okay, I will be making it available today and tomorrow. Okay,
Okay, thank you, Doctor. Last time, Doctor, it will be 12 tomorrow, right? 12 at night.
Last time is not 12, it is 11:59. Okay.
Okay. Okay, no problem.
Okay.
Thank
Any
you
other
so much.
question? Okay, I got few messages. Let me check. Can you take the activity for one chapter when? No, it's okay. Okay, Muhammad Umair Muhammad, This PPT is created for chapter 3 and 4, okay, for 2 chapters. Okay, good. Thank you. Welcome, all of you. So, any other questions?
So they have fast way to contact you if something happen.
No problem, you can.
Okay, doctor. Do you have WhatsApp?
No, in the session itself, you can. I didn't get you. You have any problem regarding what?
If something happen, internet is go down, something like that. Because for me, I am with you in 4 subject.
Mhm. No, the thing is, okay. First, you make sure that you have good proper connection. But in that case, if there is any problem, then next week you will meet me in the session, right? So at that time, you just discuss with me. I will for that, because if I open the end, then at different times I get a request, then I will be busy in only fulfilling the requests. Okay. So next week in this section, if you have any problem last week, you can discuss with me now, and I will open today.
Okay,
Next week.
doctor. Is there any problem if you give us your WhatsApp number to just message you if something is happen? Just for one of us. He will make contact
Uh,
with others, organize the stuff with you. If something having quizzes, anything
okay,
else.
okay, no problem, no problem. You can. Okay.
Okay, no problem. I'm gonna give you my personal email.
1 minute. Yeah, just a minute. I will just send you my. You tell me your Rakam Jame. Muhammad
Okay,
Ahmed. Please tell me name.
44.
1 minute. 1 minute. Abdullah Muhammad Ibn Mari.
Yes.
1 minute. I will just send you. Hmm. Abdullah Muhammad. Okay.
Okay, thank you so much, doctor.
Any other questions?
No, thank you.
Okay. You're welcome, Muhammad Ahmed Al Baqi. Thank you very much. So, wish you good day, all of you. Yeah, Sami Muhammad Abdul Rahman. Thank you very much.
Okay,
So,
doctor, thank you so much.
okay. Thank you, all of you.
Can we leave now?
Yeah, you can leave now. Thank you.